Today we're talking about the half angle formulas. Now your trig chart also calls these the power reducing formulas. Come on in. Thank you, Brooke. So the purpose of these is similar to the purpose of all those other formulas that we've seen. And that is when you have a more complex expression, a complex trigonometric expression, and you want to simplify that down. Maybe you have, you're modeling something, modeling some sort of mathematical process or physical process, and you end up with something that we'll see here in a couple minutes, a very, very large trigonometric expression. These formulas that we're going to figure out how they work are used to take something that's a complex expression and simplify it down. Okay, and so we're going to figure out how these formulas were derived, and then we're going to plug in some basic numbers, make sure we know how to use them, and also solve some other problems with them. Okay, so here we go. Our first formula is going to start like this. Cosine 2 theta equals 2 cosine squared theta minus 1. That's one of the formulas that we saw on Monday. That's one of the double angle formulas. Y'all remember the double angle formulas where there was the sine of 2 theta that everybody likes, it's just 2 sine theta, cosine theta. But then there was cosine 2 theta, which we didn't like so much because there were 3 different versions of that. Remember that, Andrew? Like where they had those 3 versions? So, starting with this one, some math nerds said, hey, we got an idea. Let's go ahead and rearrange this and see what we can find. All right? So here's what they did. Add 1 to both sides. So we've got cosine 2 theta plus 1 equals 2 cosine squared theta. And they said, let's divide both sides by 2. Divide by 2. Divide by 2. And I'm going to write that cosine squared over here. Cosine squared theta equals, and I want to make this look like your formula chart. Instead of writing cosine 2 theta plus 1, let's write 1 plus cosine 2 theta all over 2. So just sort of manipulated that original equation to resemble this. Now, if you'll notice, this right here is your power reducing formula that's on your trig chart. However, Andrew, what's the difference there between what we have here on the board and what's on your paper? Yeah, instead of theta, they've got U. Okay, so that's a good formula. But there is another one that's also sort of equal to it. And I would recommend that you write this formula off to the side on your actual trig chart. And that is, you take the square root of both sides. So help me out, class here. What's the square root of cosine squared theta?
Cosine theta.
Cosine theta equals, and we'll take the square root of this whole thing over here. So plus or minus the square root of 1 plus cosine of 2 theta all over 2.
That's for half formulas? Half
Yes.
formulas?
Technically, this one over here is the power reducing formulas. They're also known as the half angle formulas because if you notice, the relationship between this theta over here and this, which is over here, is that this one is double what you have over there. Or, looking at it from this side, that is half of this. Let's throw just some numbers in there just to see if you can figure this out. What if I add cosine of 40 degrees? Read off to me, Jaji, what's that going to equal on the right-hand side?
1 plus 400.
Cosine, it's not going to be 400.
It's not 2 times 40?
It is 2 times 40.
Oh, well, I just went ahead and do
80.
80.
that. Yeah, there you go.
80 degrees over 2. Cosine's a little ugly there. Right, okay, so we can add, we can plug in those other numbers and stuff like that. That's how this works. Okay? It won't be too bad when we get to problems, but I want to show you the other two formulas before we do that. All right. Yeah, I'll leave that up there. Here's another formula. So somewhere had a lot of extra time to manipulate equations to make their life easier, and they said, let's start off with that other form, cosine 2 theta, 1 minus 2 sine squared theta. Notice it's just another one of those versions of cosine 2 theta. And they said, let's play the same game we did over there. So let's subtract 1 from both sides. Cosine 2 theta minus 1 equals negative 2 sine squared theta. This time, divide both sides by negative 2. So the negative 2 cancels. We'll put the sine squared over on the left-hand side. Yes, Chloe?
Oh, do those two actually equal each other?
Does this? Yes.
Okay.
That's what the.
Yeah, I know.
It just looks weird.
Yeah.
That, right. If you look back on Monday, we built this.
Okay.
Were you here on Monday? Okay, we got the notes for you. That's, do you see where, can you find this on your trig chart?
Yeah, I found it.
Right hand column, second one down, okay. Stephanie, you look like you got a question back there, everything all right?
Do you mind if I turn it on?
Go for it, that's fine. 5th period has to deal with it all the time. All right, so I'm swinging that sine squared over to this side, and I'm going to swing this one over here.
That's cute.
You can hear when it ends. You know, I think my washer makes the same sound. Anybody have a washer that kind of beeps at you? Yeah.
Mine sings.
And the only reason it does that is because it's a
Mine
door
is
washer,
going.
because our other one flooded the garage a couple years ago. All right, so I'm going to do a couple things here. We've got a negative in the denominator. What we can do is we can actually push that negative up to the numerator, but that's going to change the sign of everything. It's going to, the SIGN, that's going to change that cosine into, to a negative cosine 2 theta. As we turn that negative 1 into a positive 1. All over positive 2. And then we like everything to match as much as possible, so I'm just going to rearrange this so that it resembles the cosine squared term there. So sine squared of theta equals 1 minus cosine 2 theta all over 2. Gia, what's the difference here between the sine squared and the cosine squared? Or
Sorry, I don't like that sound.
Minus.
He's jumping in for you. Yeah, it's just the minus right there.
Sorry,
Well, we've got a
Let's
1
hear
minus
this.
here. We've got a 1 plus here. So this is a good formula. This is the one that's on your trig chart, except that they're utilizing u instead of theta. No big deal. So you might say, is there an alternate form of this? Just like there was over there. Yep. Take the square root of both sides. Andrew, square root of sine squared theta. Sine theta, I agree. And square root of this right hand side, Emily.
Plus or minus the square root of minus cosine.
Whoa.
theta over 2.
Yep. I would recommend that you write this on your trig chart just for easy reference.
Sine theta? Sine theta or cosine? Oh.
Sine theta equals plus or minus square root of 1 minus cosine 2 times theta all over 2. Let's apply this knowledge. Jaji, I'm going to give you a chance to redeem yourself here.
I don't think you should.
You don't think I should?
No.
Alright. Sine,
Not here.
you got this one, I believe in you. Sine of 50 degrees equals, I'll get you started, plus or minus.
It's 100.
Yeah, it is 100.
Yeah.
1 minus cosine of 100 degrees all over 2.
Hi, Rachel.
Alright?
You're so
You're fine on that. Alright. That's 2 out of 3.
It's 1,000.
That's a degrees.
No, isn't it 50 times? Oh, never mind. I thought that was a 20.
Oh, no, yeah.
Because it looked like a 20.
2 theta for
because
2
it
Death
looks
Star.
like it's funny.
That looked like 2 theta.
Alright. We've dealt with sine, we've dealt with cosine. I want to show you tangent. So we know from our tangent and cotangent identities that tangent is equal to sine theta over cosine theta. Alright? So what I'm going to do now is I'm going to plug in the sine and cosine that we just found, these crazy expressions for sine and cosine. So instead of sine, I'm going to write the square root of 1 minus cosine 2 theta over 2.
Oh.
Big bar. Instead of writing cosine, I'm going to write the square root of 1 plus cosine 2 theta over 2.
The one.
DeMarcos, you're making some noises there.
Hmm?
You see I just plugged that guy in for sine,
Yeah.
and I'm not going to circle with this pen, but, and that right there for cosine.
Mm-hmm.
Alright. Believe it or not, mathematicians don't like to leave things ugly, and this is pretty ugly for us. Alright? So, what we're going to do is we're going to, a couple things. First, realize that if you have a square root of a fraction, you could actually, we have a square root of this and a square root of this. We could split this up as we write the square root of 1 minus cosine 2 theta divided by the square root of 2 divided by square root 1 plus cosine 2 theta divided by square root of 2. So if you remember, we did this at the beginning of the year, property of square roots, if you have the square root of a fraction, it's equal to the fraction of the square root. And then, oh, maybe I should put it down. The reason why I want to do that, which should be farther down, is because I'm going to take this numerator, and then instead of having the numerator divided by the denominator, I'm going to write that numerator times, flip it, reciprocal to the denominator. So here we go. Square root 1 minus cosine 2 theta over square root 2 times,
Square root 2 on top.
she's got it, over
That whole long thing. Square root 1 plus.
cosine 2 theta.
And then the square root 2's cancel out.
Ding, ding, ding. And we end up with
Square root of 1 cosine 2 theta over square root of 1 plus cosine.
there you go, so good.
Can
One
you
plus-
square both to make it easier? Or
Not without squaring the other side.
what's the other side?
The other side is tangent.
Okay.
Don't worry. It's not going to blow up on us. Alright, so tangent theta equals the square root of this over the square root of that. That, you might say, looks kind of ugly, but we're going to be satisfied with that. If you look on your trig chart, that's what you have. Oh, you know what? They don't have that.
Yeah.
Hold on. Moving on up. They do square both sides. They square the left side and have tangent squared theta, and they square this side and have 1 minus cosine 2 theta over 1 plus cosine. Sorry.
Or would be our final, the one we just solved for.
Yeah, kind of. Yeah, I'm gonna, you are correct. So, if you want to, on your paper, and I recommend it, I would write, or tangent theta equals, now remember, if you've got a square root of the numerator, square root of the denominator, you can put that radical sign over everything. So you can't say square root, or plus or minus square root, 1 minus cosine 2 theta over 1 plus cosine 2 theta. But this is what I found out, and I didn't know this until I was researching. I'm just going to erase this. That there is another secret version of tangent theta. Okay?
Tangent's
I'm,
just right
I,
up.
now here's the thing, I'm not going to do these derivations here. but you do need to know that there are alternate versions of tangent theta. And here's one of them. Sine of 2 theta over 1 plus cosine 2 theta. It's not much actually to go that route, but anyway. Or tangent theta equals 1 minus cosine 2 theta over sine of 2 theta. So there's actually 1, 2, 3, 4 different versions here that we need to be made aware of. These green ones are the ones that Alex on your homework likes. That's why you need to have those written down.
Come on, Alex.
There's so many different formulas in that. It's really
Horrible.
what's that?
Nothing. It's really horrible.
Yeah, that one's for Cody.
What do I need to like move?
Thank you.
You bet. All right, let's do some problems together, shall we? Go ahead and read through that first one while I take the picture.
Use the power to cosine. Cosines.
Cool, you got all this? Everybody good? All right, DeMarcos, read that problem to us, please.
Use the power reducing formulas to rewrite cosine to the 4th power x in terms of the 1st power of cosine. Simplify your answer as much as possible. To indicate your answer, first choose one of the 4 formed below. Then fill in the blanks with the appropriate numbers.
Alright, now you might say, cosine to the 4th, that seems pretty simple. All these other things seem a little bit crazier. That doesn't seem like I'm getting more simple. The answer is yes and no. Cosine to the 4th is going to be some number between 1 and 0, or between -1 and +1. And you take that, if you were going to take that number and multiply it by itself, and then by itself, and then by itself again, then any error that you happen to have in here is going to get propagated all the way through. All right? We've seen that. If we can reduce the number of multiplications and then also just have some additions and subtractions, that's going to give us a more accurate answer. So one of the reasons why we're doing this is not just to simplify it, but also to make sure that we have fewer operations, multiply operations, that is. All right, so cosine to the 4th. Jaji, I'm looking at the trig chart, and I'm not seeing any cosine to the 4th.
That's because we don't have that.
Do I need to give you a new formula?
No. Just substitute the 4
What do you mean by substitute before?
for the equation.
Okay, well, which equation do you like then?
Let's see. I like the one that starts with cosine.
The power reducing formula.
Okay, yeah, it's probably a good idea to look on the ones that we've been talking about.
Yeah.
All right, Gia, pick up the conversation here. Which one do you like? Sine squared, cosine squared, or tangent squared?
Wow. They
Oh,
all say
oh.
cosine.
Oh, okay. You're looking down here. Are you looking down here? All right.
I was talking about picking cosine from the power reducing formula.
Okay.
Yeah, that's what I thought.
I
you
agree.
was talking
This
about.
is the way that we're going to write our answer. So basically, our answer is going to be one of. It's.
Were
Gonna
you
look like
asking
this.
us for one of those?
No, I'm not. I thought maybe you were.
No, I was saying
Okay.
the cosine one.
You are both on the right track then. Okay, so yeah. So we don't have a cosine to the 4th, but we do have what?
Cosine squared.
We do have cosine squared. Can I write this in terms of cosine squared?
Yes.
Maybe cosine squared times cosine squared? That's what they're wanting to do on that first step. Then, let's just right in the other side of the equation. So cosine squared we saw was 1 plus cosine, in this case it would be 2x over 2, and 1 plus cosine 2x over 2. Everybody good? Now I know I told you though I would never do this again. Guess I'm a liar. But does
2x.
anybody remember
Oh.
a plus b times a plus b?
Yes.
What is that?
It's B squared.
There is a b squared at the end, yes?
Plus
Oh, plus
AB,
AB.
2AB.
2ab. Alright, now let's apply it. What that means is it's the first thing plus 2 times the first thing times the second thing plus the second thing squared. First thing squared. So, look, do you see the numerators here, DeMarcos? Do you see how it's a plus b, a plus b? Look at the numerator. A plus b, a plus b.
Uh-huh.
So, first thing squared, 1 squared is 1. Plus 2 times the first thing times the second thing. Plus the second thing squared. So that's going to be cosine squared of 2x.
Oh, one time. Where'd you get the 2? Why are you multiplying 2 times 1?
Anybody helps out? Why am I multiplying out of a 2 right there?
Cause,
The A and the 2AB.
Okay, so 2 and then.
DeMarcus, you totally agree with this statement, right?
Yes, I do.
This is the formula for when you're multiplying two things together that are a plus b.
Okay.
So the formula is, it's the first thing squared plus the number 2 times the first thing times the second thing.
Okay.
That one's a
Number
given.
2 times the first thing times the second thing plus the second thing squared.
Okay.
Now, 2 times 1 is what, class?
2.
2, so I'm just going to leave that as a 2. The next thing I'm going to do is the opposite of what you normally did in junior high. Normally in junior high, when you had fractions, you like to combine them, right? Now I'm splitting them up. I'm going to split this up into 3 fractions. I'm going to say 1 divided by 2 plus 2 cosine 2x divided by 2 plus cosine squared 2x divided by 2. This is something that you're not used to doing. Normally, you're used to having fraction, fraction, fraction with a common denominator and then combining all of them together with the numerators. But now we're splitting it up. Okay? And I know that 2 divided by 2 is 1. And I'm going to rewrite this one over here as 1/2 cosine squared 2x. So right now we have 1/2 plus cosine 2x plus 1/2 cosine squared 2x. Any questions so far?
Can you go over how you went from the parentheses to the one large number one more time?
I have a fraction times a fraction, and when you do that, I did not specifically say this, but you know, fractions, you multiply the numerators and you multiply the denominators. Ooh, I made a mistake here. Let's multiply the denominators first. What's 2 times 2?
4.
Okay, so I wrote 2 right there, so I'm sorry. It should be 4. Which means when I split this up, this should be 1/4 2 cosine 2x over 4 and cosine squared 2x over 4, so I use pencil. And so this is 1/4. That 2 and the 4 reduced to a 1 and a 2, so this should be 1/2 cosine 2x, and this right here should be 1/4. I haven't answered your question yet, but we fixed a problem that was present. Have we got that fixed on the paper? Alright, so Jaji, to answer your question, I've got a parentheses, like a 1 plus cosine 2x, 1 plus cosine 2x. That follows the a plus b times a plus b pattern. And so I have the numerators multiplied together equals this thing, and the denominators multiplied together equals that thing. Is that better? Okay. Other questions? Yes, Chloe?
If you had 1 times cosine 2x over all over 2, would that be the same thing? I'm the very last
Oh, the bottom.
in the middle.
1 cosine 2x over 2.
Yeah. Would that be the same thing?
If I had 1 cosine 2x
And then all of that over 2?
over 2, yes, absolutely, yes. You're saying like, couldn't we write this as cosine 2x just over 2?
Yes.
Mhm.
Absolutely, yeah, because you're divided by 2 is the same thing as multiplying by half, right? Okay, but if I look over here on my answer choices, and I know this, you maybe not, they don't want you to have the cosine 2x over 2, that's not, they want to have that coefficient up front. So let's go ahead and look and see if this matches any of our answer choices. Something plus a number times cosine of 2x, all right, plus something times cosine squared of 2x. Uh-oh.
No, we don't have square.
We don't have a cosine squared. We have just a cosine right here. Now we can put a 2x right here, but we don't have the option of putting the squared here. And in fact, if you look at the instructions, it says that we need to reduce this in terms of the first power of cosine. So that means we need to break this guy down into just cosine. Okay? So, what I'm going to do, I'm going to copy that up here for a second. Well, I don't know if I can do that. Cosine squared 2x. I have a formula for cosine squared, don't I? That formula is on my formula chart.
1 plus cosine.
It was cosine squared x equals 1 plus cosine 2x over 2. So I'm going to apply that formula. I applied it up here. I'm now going to apply it again right here. So the 1/4 stays the same. The 1/2 cosine 2x stays the same. But this 1/4 right here, I'm going to say 1/4. And instead of saying cosine 2x, or cosine squared 2x, I'm going to say 1 plus cosine of something over 2. So I'm just replacing that cosine squared 2x. Does anybody want to make a prediction what's going to be inside that parentheses right there? Cody, you've been quiet here.
Wait. This one.
You getting a glare, Jody?
Yeah.
Well, I can fix that. Y'all look at.
Okay, I'm also blind.
Just move up anyway. Cody, what do you think?
Is it 2 theta?
No, not 2x, or it's not 2 theta. What's that?
4x.
It's 4x. What in the world? Alright. Look what we had here. We had cosine squared of 2x. The formula says anytime you have cosine squared, whatever number you have here, double it when you're right there. So in our case, doubling 2x is going to be 4x. DeMarcus, does that make sense?
Yeah.
Alright. So I'll keep the 1/4 plus 1/2 cosine 2x plus. I'm going to pull this 2, which is divided by Chloe, just like we saw a second ago. I'm going to pull it out as a multiplier. So I've got 1/8 times 1 plus cosine 4x. And then I'll distribute that 1/8. So I have 1/4 plus 1/2 cosine 2x plus 1/8 plus 1/8 cosine 4x. Almost finished. 1/4 plus 1/8. Those two terms can be combined.
Oh.
This is wild.
It is. It's kind of kind of the upside, it's trade-off with math teachers here. You either get the math teacher that does everything in 3 steps, but you don't know what happens in between the steps. Or you do the math teacher that gets it in 20 steps, and you write everything down, but then you know what happens on each step. I'm trying to be that 20-step teacher. 1/4 plus 1/8, we need a common denominator. The common denominator is 8. How can I get 1/4 to 8?
Multiply by 2.
Multiply by 2, so I've got 2 8s. So 2 8s plus 1/8 is 3 8s. So 3 8s, 1/2 cosine 2x plus 1/8 cosine 4x. Awesome, thank you.
3/8.
These are the lucky persons. Good Marcos.
Oh, mercy. Why is it 3 on the top of that?
Why is it 3?
Okay.
Because when you add fractions, you keep it, if they have a common denominator, you add the numerator.
Yeah, I would.
Ooh.
Yeah,
I
know.
still saw the 1/8 over there, and I thought it was the same 1/8, but there's double.
Yeah, we're at the point here. It's kind of fun. It's also a little scary. We are pulling from all your math. We're breaking up fractions. We're pulling in your adding fractions. We're distributing. We are making sure we really know how to use that formula. You know, I mean, we're doing all kinds of stuff here. Turning division of a fraction into multiplication. You know, so all kinds of stuff. This format looks like, I think, option B. So we would bubble in that circle and we'd say 3 8 plus 1/2 cosine 2x plus 1/8 cosine 4x.
Wow.
The next one is-
shortcuts?
Nope.
Wow. That's a lot.
But most importantly, do you have a question about any one of these steps?
Where did the
Okay,
2
go
go on when you, where it says 1 plus cosine 4x over 2? Did you multiply that by 1/4 or something?
This 2 in the denominator?
Yeah, where did that go?
Yeah, I pulled that out. Remember, dividing by 2. See if this sentence makes sense. Dividing by 2 is the same as multiplying by 1/2.
Yes.
You agree with that statement, right?
Mm-hmm.
So, I'm dividing all of that by 2. Well, that's the same thing as multiplying all of it times 1/2.
So 1/4 times 1/2 is 1/8?
That is correct, because the fraction multiplication, you multiply the numerators, 1 times 1 is 1. You multiply the denominators, 4 times 2 is 8.
Why did you only do that one?
Why did I only pull the 1/2 out once?
No, and only put it into the 1/8, not into like the 1/4 and the 1/2.
Not into those because it's only, because there's a plus right here, and it's the 1/4 is the only thing that's
Okay, so it's like backward distribution.
yes, it's like it's like I pulled it out, it's like I factored it out.
Can you explain how you broke it down into the 1/4 plus 1/2 cosine 2x plus 1/4? Wait, you have that from over here.
Yep.
And
How
then,
I split it? How I split one fraction into 3?
No. So wait, you just grabbed this and then you rewrote it over there.
Almost. The only thing
and
I
then
changed.
you added the.
In what I have circled here is inside the brackets here.
Because that's another equation.
That's utilizing our brand new equation that we just learned. Is that cosine squared of blah is equal to 1 plus cosine 2 times blah all over 2. Good questions. Chloe? Andrew? Emily, Cody? Alright, let's do another one. It gets faster. Alright? First one just always seems to take a long time. Alright. You might need some extra paper just because I don't know if there's enough room on that sheet there for you. And these problems, if you can just get the very first step or two down. Alright, this says cotangent squared of 5x times sine to the fourth of 5x. Alright, as a general rule, we don't like the reciprocal identities, cotangent, even tangent, secant, cosecant. One of the first things we want to do is we turn everything into sines and cosines. Okay? So cotangent can be written as, who's got the reciprocal identities memorized or readily visible? Cotangent is what over what? What's that?
1 over
X over y? No, what about in terms of sines and cosines?
1 over
over
tan
tangent.
x
1 over tangent x, or in terms of sines and cosines?
cosine x over sine x.
Alright? So it's cosine over sine.
Oh yeah, because cosine over sine is tangent.
Yeah. Then this. Now the angle here is 5x, so it's going to be cosine 5x over sine of 5x. And notice we have cotangent squared, so that just means like we would square this whole thing, or we could square each one of those individually. So it's cosine squared 5x or sine squared 5x times sine to the fourth 5x. Now if you remember, sine squared means sine times sine. Sine to the fourth means sine times sine times sine times sine. So we've got 4 of these suckers and 2 of these down here. And they're all being multiplied times each other, so we can reduce them a bit. That will cancel out all but 2 of those. So we have cosine squared times sine squared. Now, to make this clear, because I felt like there was a little bit of confusion the last time, go ahead and read off to me from your trig chart cosine squared of u.
1 plus cosine 2u over 2.
And sine squared of u.
1 minus cosine 1 minus cosine 2u.
Okay? Notice I have a cosine squared and I have a sine squared. So I'm just going to utilize our formulas and replace both of those. Alright? So replacing the cosine squared with this one right here. Somebody read off to me what the formula is going to be, but not Emily.
Wait.
1 plus cosine, and then would it be 10?
Yes! Awesome. That's what I was hoping for. 10x.
10x.
Because it's
Well,
2.
Because the thing that's over here is 2 times the thing that's over there. Here we had 5x, so since I'm going over this, it's going to be 2 times 5x.
Yeah, I got it.
That's the hardest part to get on these problems, in my opinion. Alright, somebody else, read off to me, replacing the sine squared 5x.
1 minus cosine 10x over 2.
Great. More side problems. Oh, I'll tell you what. Jaji, you asked last time, how did I go from a fraction times a fraction to one big fraction?
Yes.
Are you okay with doing that again?
I don't really think I'm gonna get it.
You don't like it? Okay. Let me show you one intermediate step here. Okay. Here you go. So, a over b times c over d equals. Someone remind me on fraction multiplication. How do you do fraction multiplication?
You'll keep the AB and the flip the CD.
That's division.
AC over BD.
A times c over b times d.
Would it be 1 plus cosine 10x, 1 minus cosine 10x over 4?
So we have 1 plus cosine 10x times 1 minus cosine 10x all over 2 times 2, or usually we write 4.
4.
Yeah, but on those one you had like
No, because
4,
he
2x.
you had
X
1 over
squared.
2 plus cosine 10x over 2.
Right.
1
That's
over...
yes. Because I was being that 3-step math guy for a minute, and I was doing 2 things at once.
Right, so then how do
So-
you get there?
Okay,
Distribute?
what we have here is an A plus B times an A minus B situation. Alright, so, I know I said I'd never do this again, but I guess I'm a liar here. Does anybody remember from Algebra 1 or Algebra 2, A plus B times A minus B?
A squared plus B squared.
Minus
Oh, minus B squared.
A squared minus B squared. So what that means is the first thing squared minus the second thing squared.
So 1,
The 1 squared is
1 minus cosine 10x squared.
The way we write
Cosine
cosine, yeah, cosine squared
Oh.
of 10x. All over 4.
Why don't we have it out? Like, why don't we have cosine 10x squared?
Why don't I put the squared right here?
Yes.
Because that would mean, like, take 10x, multiply it by itself, and then put that inside the cosine function.
Okay.
Alright, next step, break up the fraction.
1/4 minus cosine squared 10x over. Oh, what?
But instead of writing it as over 4, I'm going to write cosine squared of 10x.
Why do you have 1/4 cosine?
It's the same as.
Would you like me to write it as cosine squared 10x over 4?
Oh, yeah. That makes no
Cosine
sense.
squared 10x over 4. But we know that is going to equal 1/4 minus 1/4 cosine squared. See, this is why you have to ask the questions. If you don't ask the questions, then I won't know that you don't get that one step. I read one step, now you get it. We're good. Little side note, in college, unless you speak up, your professors won't figure out that you don't know it. When I was in college, the guys that made the high A's were the ones that went and talked to the professor after class. All the rest of us made the low A's because we didn't want to talk to the professors. All right, we've got 1 minute left. Let's see if we can fix this. Unfortunately, we have a cosine squared here. Okay, so I'm going to write this as 1/4 minus 1/4 bracket, and I'm going to utilize this same formula again. And instead of writing cosine squared of 10x, I'm going to write 1 plus cosine of 2 times 10x.
20x?
20x. All over
4?
2.
Oh, what?
Because
Oh,
that's
yeah.
part of the given.
That's the formula.
Take the 2 out.
I can take the 2 out, so I've got 1/4 minus 1/8, 1 plus cosine 20x. Carrying it up here. I'll distribute that 1/8. So I have 1/4 minus 1/8 minus 1/8 cosine 20x. 1/4 minus 1/8, I'll just tell you real quick, that's just 1/8. So 1/8 minus 1/8 cosine 20x. I told you the second one would be faster.
So it's the third one?
Yep, it would be the third option. You would fill in those numbers. 1/8 minus 1/8 cosine. All right. Tomorrow we'll wrap up the other 2 problems. They're not too bad. Okay.
Oh! I won't be here tomorrow.
Then we'll have the video recording for you. All right.
Turn.
So
How did you eliminate the 1/4?
1/4 minus 1/8 is 1/8. Okay. 1/4 can be written as 2/8.
Oh.
And 2/8 minus 1/8 is 1/8. It does look like I just dropped the 1/4 out of it, but I did not. Okay. Then we talked about the power reducing formulas, where they came from, and how to use them.